Y'all said that opposite sides have to be parallel. What else?
Diagonals intersect.
Diagonals bisect each other. What else? Opposite angles are congruent. Opposite sides are congruent.
Consecutive angles are supplementary.
Consecutive angles are supplementary. Okay? All those things are still going to be true today because we're going to keep doing parallelograms, but now we're going to upgrade the parallelograms. Okay? They're going to get specialized. And so the first specialized one we're going to do is this fella. Remember the rhombus? Remember that guy? Any of you ever had to do that before?
Yes.
Okay. Someone tell me something that always happens when you have a rhombus.
Parallel.
What's that?
All sides are equal.
All the sides are equal now, not just the opposites. So, yeah, this is always true in a parallelogram, and this is always true in a parallelogram, but in a rhombus, it's all of them. And of course, you know what this means. You can make an implied statement.
Oh.
So a rhombus is going to imply, now, here's copy this exactly. You have what was this symbol again? Parallelogram with 4 congruent sides. Okay? Why is it extremely important that you put the parallelogram in the implied statement? Yeah? Well, no, that would be acceptable. Well, what if I did some random shape like that that had 4 congruent sides? Is that a rhombus?
That's why.
Yeah, it is very, very strange. But is it a rhombus? No, because it's not a parallelogram with 4 congruent sides. Okay? So yes, in the implied statement and on your implied statement sheet, it does say parallelogram with 4 congruent sides, because otherwise you might have something goofy like this with 4 congruent sides. And we don't want that. Okay? There is a method to this madness. Okay? What else? Yeah? Well, the opposite angles being congruent was always going to happen because it's a parallelogram. That doesn't change when you make the sides congruent. Okay? But something else changes, so I'm going to show you. Just going to, and for those of you on the video, I'm playing a game, so just, sit tight. So here I have, oh look, yon parallelogram. Okay?
Yeah.
And so what do you notice about the diagonals that's going to be true for every parallelogram? They're bisecting each other. So this side is congruent to this side. Cool. Now I'm going to turn it into a rhombus. Now all 4 sides are 1 foot long. The diagonals are still bisecting, aren't they? So since it's a rhombus, it's still a parallelogram. But something different has now happened with those diagonals. Something new and upgraded has happened now that it's a rhombus. They're perpendicular now. And they were already bisectors, so now they're perpendicular bisectors. Diagonals are perpendicular to each other now. And it doesn't matter which way I do the angles. Whichever way I stretch this, even if I make it kind of squishy down here, they're still perpendicular to each other. No matter how you stretch it out in a rhombus. Okay? So we get to come do that over here. So what you're going to do is you're going to draw one diagonal. You're going to draw your other one. And so if you have a rhombus, you're going to have perpendicular diagonals. Does that happen in every parallelogram that exists?
Yes.
No. That only happens in the rhombuses. Okay? So when you get this particular special parallelogram, this is when you get to have perpendicular diagonals. Okay? So if you don't know it's a rhombus, you don't know that this happens. Okay? What makes a rhombus again? Four congruent sides. So if you have congruent sides, that means you're going to have perpendicular diagonals. Okay. Got it. Now, I'm going to play a game on here. I don't want you to write anything down that I'm doing. Okay, because it's going to be a mess on your sheet. But I'm going to put some stuff down. I'm going to redraw these diagonals. Okay? And go, okay, what do I know about these diagonals in this rhombus? They're bisecting each other. They're perpendicular to each other. Are they congruent? Do they look congruent?
Yeah.
I don't know. Well, check this out. In a parallelogram, the more you flatten it, look at that yellow one. So see how it's stretching? And the green one's getting smaller? Okay, so they're not the same size. And when you get in a rhombus, oh look, the same thing happens, huh? One gets longer and the other gets shorter. So no, the diagonals are not the same length. But you do form triangles, all right? So I've got this triangle, and I've got this triangle. What do I know about the sides of those triangles? Well, these ones are congruent, right? And this one's congruent to itself, isn't it?
Yeah.
Oh, which of my congruent triangle properties do I now need? Side, side, side. So I just made two congruent triangles, didn't I? Two congruent red triangles. So rhombi divide into congruent triangles. But wait, there's more, because what do congruent triangles imply? Congruent corresponding parts. Because it isn't just the angles, is it? Okay? So, oh wait, the angles are going to be congruent. So check this out. This angle right here is going to be congruent to that angle right there.
Yeah.
And this one here is congruent to this one here. But weren't these big angles already supposed to be congruent? Weren't opposite angles supposed to be congruent anyway?
Yeah.
So now, not only are opposite angles congruent, they're cut into two congruent adjacent angles. What do congruent adjacent angles imply? Angle bisectors. So if you have a rhombus, the diagonals bisect the opposite angles. So, a new implied statement. So the diagonals bisect opposite angles. Does it work both ways? Well, if I do it with the blue line here, will I still get congruent triangles going the other way? Yeah. And so I will still have congruent angles here and congruent angles here. Oh, but wait. If I have two congruent angles and I cut them both in half, what's going to be true about all the halves? If you have two things that are the same size and cut them both in half, what's true about all the halves? They're all the same. So these little angles down here are both equal to these little angles down here, and these little angles here are congruent to these ones. Would that be true with segments too? Oh, let's keep that in mind for later. So let's play around with this. I want you to take a minute and using what you remember from the Dark Ages plus these three new things, figure out all these angles. I'll give you about a minute and a half. As soon as you figure one out, tell me, and I'll give you candy. Yes, what did you find? 3 is 90. How do you know it's 90? The diagonals are perpendicular, which makes it be 90 degrees. Okay, we've got that one. Yes, you have one?
4 is 90.
4 is 90. Why is 4 90?
Because it should also
Perpendicular diagonals, and perpendicular implies right angles, which imply 90 degrees. Okay, another one.
2 is 35.
How do you know 2 is 35?
The diagonals bisect opposite.
The diagonals bisect. Okay. Now we're getting to the ones, oh, by the way, guys, angle 6 here is talking about this whole thing, and angle 5 here is talking about this whole thing. How big is angle 5? How do you know it's 70? This whole angle here is 70 using your angle addition, and since a rhombus is a parallelogram, you know that the opposites have to be the same, so this one's 70, and so you can go get a prize as well. Okay, so angle 5 is 70. I also have, for those of y'all who are fasting for whatever thing, I also have like stickers and stuff if you need something instead of candy. Okay, more. Give me more. Yes, Jackson?
1 is 55.
How do you know 1 is 55?
Wait.
You gotta think about it? Okay, well, while you think, somebody else, don't do angle 1 for a minute because he thinks he's gonna get it, and in the meantime, what do you got, Nassim?
6 is 110.
And how do you know 6 is 110?
This is the same size as angle 1.
But I don't know how big angle 1 is.
Well, it's like if you look 4 is 90 and the other one's 35, and you have to add up to 180.
Oh, so could you use this little triangle to figure out how big this little angle is? You could. And then you could double it. That would be one way. What's a different way to get this angle? Because he says, yeah, angle 6 is 110, and it's true, but what was a different way to tackle it that required a little less work?
You subtract 140 from 360.
You subtract what?
140 from 360.
Oh, you could say, I know that a quadrilateral always has 360, so subtract the 270s from it and then divide it in half. That's another long way. Yes?
Oh, no, I was...
Okay, we'll get to yours. We're still trying to figure out angle 6. What was one of the properties of a rhombus about its angles? It wasn't just opposite angles, was it? The consecutive angles had to be supplementary. So that also makes it 110. Oh, but wait! If consecutive angles are supplementary, how big is this big angle down here? 110. And then, Jackson, how do we get angle 1?
2, because you found out that 2 is 35,
Mhm.
and 2 is 90 degrees, you just add them together and subtract it.
Yeah, so you could do the subtracting from 180 thing, or could I use the 110 and just divide it in half since I know that it's an angle bisector? Yeah, there is more than one way to solve these. And I don't care which way you use, as long as you get it. There's 1,000 different proofs for the Pythagorean theorem, and nobody's complaining about it. We're really happy to confirm stuff. Okay? So there you go. So you're going to get...
10.
Oh, it's 55, get candy. See, you got to catch my mistakes. That's what I need y'all for. All right. So that was your rhombuses. You're very excited. Let's do something worse. Let's take our parallelogram and let's don't make the sides be congruent yet. Let's let, I want those sides to be a little bit longer. Yeah, something like that. Could have like caught his head in this and like snapped it off.
Oh my God.
Yeah, that's normal. Okay, so we've got a parallelogram.
That's your twin.
How do I make it into a rectangle without changing it being a parallelogram? Just to see those? How to make a rectangle? Yes?
Make that outside inside. I get 90 degrees.
Oh, what if you made all the sides perpendicular?
Yeah, that works.
Is this still a parallelogram?
Yeah.
Check. Are opposite sides parallel?
Yes.
Are opposite sides still congruent?
Yes.
Are the opposite angles congruent?
Yes.
Yeah, 90 plus 90, or 90 and 90 are equal. What about consecutive angles? Are they still supplementary?
Yeah.
Yeah, 90 and 90 does make 180. So, okay. So, a rectangle isn't just a rectangle. Have your parents and your teachers been hiding the secret hidden knowledge from you?
Yes.
That a rectangle is really just an upgraded parallelogram?
Whoa.
Because see, here's an ordinary parallelogram. You stretch it until, oh, there's a rectangle, and oh, now it falls back to being a boring parallelogram again. You want to play with it?
No.
It's fun. I built it in 5 minutes yesterday.
How'd you make it?
I've got these yardsticks that have hinges,
Oh, I should do that.
courtesy of KDISD. And
You stole them.
no, they were given away in a come live in Houston fair back when I lived in Virginia 10 years ago. Okay? And so, yeah, a rectangle is still a parallelogram. So a rectangle is still a parallelogram, but now it has the bonus added feature of also having 4 right angles, so you get yet another implied statement out of that. 4 right angles. Do you have to write the parallelogram part?
Yes.
Could you write it as the box? Could you write the whole word if you felt like it? Could you do the little parallelogram thing?
Yep.
Yeah, I don't care. But just make sure you say that it's a parallelogram with 4 right angles, because yes, you can have other shapes with 4 right angles.
Okay, it's not funny.
Not a rectangle. 1, 2, 3, 4 right angles. So yeah, you do have to say that it is a parallelogram with 4 right angles. Uh-oh, someone forgot to silence their phone. Kitty. Okay. Now what? Wait a minute, yes?
If they're right angles and they're congruent, or congruent.
Oh!
Got it.
So, what he said was, oh wait, one of the implied statements for right angles says that right angles are always congruent. So now, instead of just opposite angles being congruent, now all 4 angles are going to be congruent. Which, I mean, it seems kind of obvious, but hey, we're math, we tell everything. So now if you have a rectangle, you can imply that you have a parallelogram with 4 congruent angles. Which, of course, everybody's very impressed by. I think you should go get candy for that. But wait! There's more. Okay? Now, in a parallelogram, are the you've got your diagonals here. Are they perpendicular? No. Oh, so then if they're not perpendicular, what do you know about this?
They're not.
It's not a rhombus. Okay? And so I'm going to take this parallelogram and I'm just going to stand it up a little bit. It's being too lazy, so let's stand up. Stand up. Now that I have a rectangle, do you notice anything interesting about the diagonals? Now look at this one. See how the green one gets longer and longer as I push it that way?
Yeah.
But as I stand it up and it gets to be 90 degrees, they're congruent. And then as I push it the other way, now the yellow one's getting longer. So right when it's in the middle at 90 degrees, that's when you have congruent diagonals. So rectangles are the magical parallelogram that's going to have a parallelogram with congruent diagonals. So this diagonal here is going to be congruent to this diagonal here. Wait a minute. when we had congruent angles and we bisected them, what was true about all the little halves?
They were
They were all congruent. So if I have congruent diagonals and cut them in half, what's going to be true about all my little halves? They are also going to be congruent. Handy. That will be quite useful in, say, oh, look, giant problems where you have to figure stuff out about a picture.
That's it.
Okay? Now, which shape has the congruent diagonals?
Rectangle.
Which shape has the perpendicular diagonals?
Rhombus.
How do you keep that straight?
You memorize your place.
You could memorize it, or check this out.
Common sense.
A rhombus had congruent sides and a perpendicular diagonal. A rectangle has perpendicular sides and congruent diagonals. Did you notice that they were opposite from each other? Yeah, this was your rhombus. Since all of its sides were congruent, you had perpendicular diagonals. With your rectangle, when you have perpendicular sides, you have congruent diagonals. They're exactly opposite each other. I didn't realize that until I was like 40 years old. So, I'm giving you like a major piece of wisdom born from long experience.
It's fountain.
Okay? Yes, you want this to help you be successful in life. Absolutely. This is going to come in handy someday, I'm sure. Okay? So using that and everything else, QRST is a rectangle. Oh wait, there's no letters on it. Yeah?
On the rectangle, no, on the whiteboard. Next to the, above the equal sign.
This?
Then that one.
Yeah, that's my bad drawing of a squiggle.
Oh.
Because I have bad handwriting. Okay? So draw the rectangle. Oh, it's drawn. What's missing? The letters. Does it matter where you start the lettering?
No.
No. As long as it's in the right order and you never zigzag. So I'm going to just start up here. And it says QD here equals x plus 16. And RS equals 3x minus 4. And angle R here is 2y plus 34. Yeah. Find x and y. There they are. Found them. X marks the spot. Now what?
Find it.
Find what they're actually worth. How? Someone tell me how I can find x, say. Somebody who wants a prize that hasn't spoken up yet, but that you feel pretty confident on this one. Or I could just pick a victim, You've already gotten enough sugar for today. Well, there's stickers too.
Yeah. Wants a sticker.
He wants a sticker?
No, I'm good.
Okay, so Grace. What's something I can set up here? There's multiple options.
X plus 16 equals 3x minus 4.
How do you know that?
Because the opposite sides are congruent.
How do you know that?
Parallelogram.
Because it's a parallelogram. But it said it was a rectangle.
A rectangle is a parallel.
Oh, yeah. You say that with so much contempt. A rectangle is a parallelogram. Golly, Miss Sorna.
As if she didn't know what it was.
As if I didn't already know anything, right? So then 2x equals, so x minus x, that goes away, add the 4, so 2x equals 20 and x is 10?
Yes. Yeah.
Wow, so scary. Once you figure out the geometry, the algebra is old hat. You've done this for a year and almost 2.
And then 2y plus 34 plus 90.
How do you know this equals 90?
Because the rectangle is a parallelogram with 4 right angles.
It's got right angles. Did you notice that the name of a rectangle tells you its special feature?
What?
See, it's a rectangle. What do you think angle is telling you about?
It's right.
Angles. What do you think the rect is telling you about?
Right.
Right. The name actually tells you its special feature. Did you not already realize this? Your teachers didn't point that out?
No.
Oh, they've hidden all the secret knowledge from you guys. So yeah, this guy has to be 90. So you just plug that in and, start working it out. And you go, okay, well that's going to be what, 56? And so y will be 28? Oh. So, the final special square. Is a square a parallelogram, a rhombus, or a rectangle?
It's a parallelogram.
Oh, it's a parallelogram. Okay, you say it's a parallelogram. So are the opposite sides congruent?
Yes.
Opposite angles congruent?
Yes.
Because they're all 90. Okay, well, great. It's a parallelogram. Is it a rhombus? Does it have 4 congruent sides?
Yes.
Does it have perpendicular diagonals?
Yes.
Yeah. Okay, so it's a rhombus, but is it a rectangle? What makes a rectangle be a rectangle? No, 4 congruent sides was a rhombus.
4 right angles.
The 4 rectangles. Oh wait, the right angles. Does a square have 4 right angles?
Yes.
And is it a parallelogram?
Yes.
So this is a stinking rectangle.
Yeah, square.
Square is a rectangle. It's just a upgraded rectangle that happens to have 4 congruent sides. But see, it's a chimera. It's got both things. So now it's also got the rhombus going on. Okay? So this guy is both a rhombus and a rectangle. Which means, guess what all the properties it has in here? All of them. So what are some of all those things it's going to have? 4 congruent sides, which, and then it's going to have 4 right angles, which means that they're all going to be congruent. What else? What do the diagonals do in a rhombus? Perpendicular diagonals. What else about the diagonals?
Congruent.
I'm going to have congruent diagonals. What else?
Perpendicular side.
Yeah, that comes from being the rectangle. It's also going to have the diagonals doing what? Bisecting the opposite angles. That's and there's more, isn't there? Should we keep going? Should we put a number 6 and a 7 and an 8? That's a lot. Do you want to have to learn that many implied statements for squares?
No.
Wait, what?
No.
These are implied statements. Okay, whatever.
Well, I could make them all implied statements. Should I?
No.
No. So instead, what we do is we say, okay, if a quadrilateral is a square, that means it's a rhombus and a rectangle and a parallelogram. Let's just make one implied statement that covers all of it. And so your implied statement sheet actually has this. A square implies that you have all the properties of a parallelogram, a rhombus, and a rectangle.
Is it by condition?
For our purposes, we're going to leave it one way. But technically, yes.
Is a rhombus a square?
Is a rhombus always a square? No, here's a rhombus that isn't a square. But is a rhombus sometimes a square?
Yeah.
Yeah, when I make it stand up and have 4 right angles, suddenly the rhombus is a square. Okay, but then you can push it back the other way and it's not a square anymore. Okay, is every rectangle a square? No, here's one that's not. What do I do to make a rectangle become a square? Make all the sides be the same length. Okay? And so, do you think those would be great questions for an always, sometimes, never thing?
Yeah.
Is a square a rhombus? Always, sometimes, or never?
Yeah, always.
Always. A square is always a rhombus. It's a rhombus that happens to have right angles. Okay? So it might be good practice to kind of, try and challenge each other on that and figure it out so that when it comes up later, you're not surprised. So, oh look, I have a square. Does it look like a square?
No.
Do you trust the picture?
No.
No, it says it's a square, so by golly, it's a square. So you know what about it?
It has
An awful lot of stuff, don't you? All the stuff. Shh. Do you want to label everything right now?
No.
Not necessarily. What are we going to be focusing on? DAC. So should I label letters first?
Yes.
Yeah. So A, B, C, D. So angle DAC is going to be this guy. And it equals 9x. So what's a property of squares that's going to be real useful in figuring out x?
Right angles.
Yeah, the fact that I have right angles, maybe? Oh, how does that help? New victim. Nikita, what do you think? What would be helpful to figure out 9x now that I know that this is a right angle?
How much x is?
Yeah, but I'm trying to find that. Rats. So how can I figure it out based on what I know? Or?
But, right equals bisected by that.
Yeah, in the square, the diagonals are going to bisect. So this is going to be half of 90, which is how much? 45. So now that 9x is 45, can I figure out x? Yeah. And it equals how much?
5.
Y'all are so smart. How many of you have done what is it called in biology when you divide up all the living things into their different domains and taxonomy? And so you've got, what are the domains?
Oh.
Kingdom.
Okay, so what are the domains? You don't remember. What about the kingdoms? What are the kingdoms? I know the kingdoms.
Bacteria.
Animalia.
Animalia, Plantae, Fungi,
And that's it.
Protista.
And that's it.
Okay. All right. And so when it breaks down, right?
Yeah.
Let's do that for quadrilaterals. You're like, why is this sort of talking biology? Shh.
This is
So you can divide the quadrilaterals into subgroups. The one we've been focusing on is the parallelograms, which of course we just talked about. Now you can have boring parallelograms, just ordinary parallelograms, okay? But then some of them are specialized. Well, that's just, nothing but parallelogram.
Oh. I was like,
Okay? But there's also some special parallelograms. What are they?
Excuse me, Miss. I can't read the orange one. Say nothing.
It just says nothing but parallelogram.
rectangular.
I've got rectangles, which are still a kind of parallelogram, and I have a rhombus. And yes, you can absolutely abbreviate these things. But what if those ones crossbreed?
Square.
Then you end up with a square.
Like 2 dogs.
Okay, so that's like when you have like the little Maltese and the Chihuahua, or the Chihuahua and the Dachshund, and you have the Chiweenie, and then you have like the Pit Bull and the Mastiff, and you get all these scary combinations. Okay? And so these are the ones we've learned so far. Tomorrow we get to learn about the scary ones. And this is not a diamond. Actually, you know what? Guess what shape is considered the diamond? A rhombus. And a square is a type of rhombus, isn't it? So the shape of a diamond is actually a rhombus that's been turned on its point. Okay? So what is this guy? That's kite. That is its actual geometric name. A kite can never, ever be a parallelogram. You cannot be a parallelogram at the same time as you are a kite. They are completely different things, just like fungi are totally and completely different from protists. Okay? What about this guy?
Trapezoid.
That's your trapezoid.
Look at me knowing my shape.
Unless you live in Great Britain.
What's it called?
They call it a trapezium. Like half the math YouTubers I watch are British. So I hear all these weird things. Okay? Oh wait! It has an evil offspring. What is the evil offspring of the trapezium, the trapezoid?
Perfect. That's what we
That's not a trapezoid, Cameron.
Well, here's a clue.
What?
Well, it has two congruent sides. Well, wait, hold on. Guys, what did you call a triangle with two congruent sides?
Isosceles.
So this is an isosceles
Oh, that's a thing.
trapezoid.
Did you not hear? Idiot. That was not very kind, Cameron.
Okay?
God, Cameron.
These guys are what you get to do next class.
Oh.
But you don't get to do them today. You have to just sit and wonder about the awesomeness that they are. Which means, since we're not doing them today, they will not be on the quiz. Okay? Now, I have 3 examples I can go through. And you're going to want some time to, possibly look at your homework. So I'm going to do one example that gives you basic idea of the stuff you're going to do. Okay? That's this first one. This is actually a really good one to say stuff. So it says, please play along nicely. It says the measure of angle JPM is 40 degrees in rectangle JKLM. What's the first thing you should do? Label it all. So I've got JKLM. Where's P? Because it says
Midpoint. Or not the midpoint.
it's the point where the 2 diagonals intersect. Right there. Okay. And now suddenly you recognize the pattern on the back of an envelope.
Oh, I didn't know. Whoa. I didn't know.
And JPM is 40 degrees, and JK is 12. Okay. And so you go, okay, find I know.
12.
How'd you know?
Because their opposite sides are congruent.
Opposite sides are congruent. Okay. What about PK? You're more right than you think. Okay, shh. If you're getting stuck and you're not sure what to do, start filling in anything else you can figure out and see if that helps you. So what are anything you can figure out about this picture?
Is KPL 40?
KPL will be 40 because those are vertical angles.
What if you look at the, I can't even talk. Wait, never mind.
Oh wait, what if this would be 140?
Yeah, these are a linear pair. So this will be 140 and 140. What are some other things you can figure out about rectangles than just those? I know that all the angles are right. So I know I have right angles here.
Are they,
You can
is
find the-
MP and PK congruent?
Are MP and PK congruent? Well, is it a parallelogram? What do the diagonals do?
They bisect.
They bisect, so yes. But wait, what else is true about the diagonals?
Don't they bisect?
They bisect the angles and they are congruent. And so if these are the same length and this is congruent, wouldn't these also be the same length? Wait a second. What shape is this?
Triangle.
What kind? It's isosceles. And in a triangle, if you have two congruent sides, you have two congruent opposite angles. And I know this one's 40. So can I figure out how much these other two guys at the bottom are?
Yeah.
Yeah.
70.
Because let's see, 40 take away from the 180 is 140 divided by 2 is the 70 here and 70 there.
And then those other angles.
But wait, Dawn, how big are the corners again?
90.
And so if this is 70, how much is left over here?
20.
Wow, look at that fast mental math. Oh! This is why we've been doing the warm-ups. Do you see it?
Whoa.
That's a right triangle. And I have one of its angles. And I have the adjacent side. And PK is a piece of the hypotenuse. Would it be helpful then to find the hypotenuse here?
Yeah.
Yeah, because that's the diagonal of your rectangle. So which trig function should I use if I'm wanting to find my hypotenuse? Adjacent?
Oh, cosine.
Yeah, the ca. So adjacent and hypotenuse. So the cosine of the 20 is going to give me my adjacent over my, what is my hypotenuse? Oh, it's MK. Could you pick any random letter? Absolutely. But instead of picking X, I'm just going to put that it's MK, so that way when I'm done, I don't have to figure out what was the X standing for again? I already know, it's the length of MK. Do you remember the shortcut for getting the MK off the bottom? Switch. Remember that? So MK now equals 12 over the cosine of 20?
Yeah.
Okay, I don't have a calculator. 12.777? Okay. And so you go, yeah, great, that's MK though. I only want PK.
Divided by 2.
You gotta cut it in half, so what's half of MK?
6.35.
6.385 garbage, so 6.39-ish? Something or other?
Yeah.
Okay, and what was PJK?
20.
PJK, that's the 20, okay? So as you do the homework assignment, if you start getting stuck, look for other things that are properties of these shapes that might click something in your brain.
Oh my God, bro. Why you keep hitting that?
Yeah.
I didn't know.
Everyone's coffee, Brad. Like, why does somebody have to do